Hello students, welcome to Anne's classes. We are doing squares and square roots, chapter 3, exercise 3a. Squares and square roots. Now what are squares? Now here we have a table and here in the first column we have numbers. Now when I multiply a number by itself, the answer that I get is called its square. So 1 into 1, 1 ones are 1. So multiply a number by itself and the answer you get is a square. 2 2s are 4, 3 3s are 9, 4 4s are 16, 5 5s are 25 and so on. So here we have numbers from 1 to 10 and here we have their squares. And then the next table we have numbers from 11 to 20 and we have their squares. Now children, it will always be good for you to learn this table by heart. Okay, because when you use them in your questions, instead of wasting time multiplying each number again, if you know this by heart, at least from 1 to 20, if you know their squares, it'll be really good. Now we have square roots. Now these are numbers here and this symbol here stands for a square root. Okay, so here what is the square root of 1? What's the square root of 4? What does it mean? Now look at this next table. Okay, now if I take 1, what are the numbers that multiply to give me 1? Which is the number which I multiplied by itself to give me this? That is 1. 1 into 1 is 1, isn't it? So the square root of 1 is 1. Now the square root of 4, which is the number that multiplied by itself to give me 4? 2. 2 2s are 4. Similarly for 9, what gave me 9? 3 3s are 9. What gave me 16? 4 4s are 16. What gave me 25? 5 5s are 25. So the number that is used to multiply by itself to give you a number, now this is called the square root. So the square root of 25 is 5. Square root of 36 is 6 because 6 into 6 is 36. Square root of 49 is 7 because 7 into 7 is 49. Square root of 64 is 8. 8 into 8 is 64. Square root of 81 is 9. 9 nines are 81. And square root of 100 is 10. 10 tens are 100. Look at the next table. Here also we have numbers and here we have their square roots. So what is the square root? The number that when multiplied by itself will give you the other number. Okay, so the square root symbol is this and the square root of these numbers are the numbers in the next column. Now some points that you can keep in mind. The squares of even numbers are always even. That is, if you take even numbers, what are even numbers? Even numbers are numbers like 2, 4, 6, 8 and so on. Now what is the square of 2? 2 square is 2 into 2. 2 2s are 4. 4 square is 4 into 4 which is 16. 6 square is 6 into 6 which is 36. So can you see these are all even numbers and their squares are also even. So the first point, squares of even numbers are always even. Next point, squares of odd numbers are always odd. So let's take a few odd numbers. What are odd numbers? 1, 3, 5, 7, 9, 11 and so on. Squares of these odd numbers. What is the square of 1? 1 into 1 is 1. 3 square, 3 3s are 9. 5 square, 5 5s are 25. So can you see here, these numbers are odd numbers and their squares are also odd numbers. So squares of odd numbers are always odd. Next point, squares of numbers, whether they are positive or negative, are always positive. That is, if you take some numbers like 2, 3, -4, -5 and take the squares, okay, 2 square. 2 square is 2 2s are 4. So this is a positive number. So plus into plus is plus, so plus 4. Now here 3 is a positive number. The square of 3 plus into plus is plus, 3 3s are 9. Now square of 4 minus 4 means minus 4 into minus 4. So first multiply the signs, minus into minus is plus, 4 4s are 16. Similarly here square of minus 5 means minus 5 into minus 5, that is the square. So minus into minus is plus, and 5 fives are 25. So what does this statement say? It says squares of numbers, whether they are positive or negative. So here we have positive numbers and some negative numbers, but the answer is always positive. Can you see? So whether the numbers are positive or negative, their square will always be positive. Next point, a number whose exact square root can be obtained is called a perfect square. That means, now suppose you have a number 9 and you can get the square root of this number. That is, the square root symbol is this, and what is the number which when multiplied by itself will give you 9? 3, isn't it? So 9 is called a perfect square because you can get the exact square. Now let's take 8, the number 8. Do we have a number which when multiplied by itself will give us 8? No, we don't have a number. We can find the square root of 8, but we don't have a number like this, isn't it? We don't have a number like this. So 8 is not a perfect square. Now take 16. The square root of 16. Is that a number which when multiplied by itself will give us 16? Yes, 4, isn't it? 4 fours are 16. So these numbers, that is 9 and 16, are called perfect squares. So what is a perfect square? A number whose exact square root can be obtained. We got the exact square root of 9 and 16. So these numbers are called perfect squares. Every natural number, whole number and integer is not a perfect square. There are some numbers which are not perfect squares as we saw here. So we can't say that every natural number is a perfect square, every whole number is a perfect square and every integer is a perfect square. No, there are some numbers that are perfect squares and there are some numbers that are not perfect squares. So now a little more on perfect square. A number whose exact square root can be obtained, like 9. We know the square root of 9 is 3. Square root of 16 is 4 because 4 fours are 16. Square root of 36 we know is 6. 6 are 36 and so on. So here we know square root of 9 is 3. Okay, so 9 is a perfect square. Square root of 16 is 4 because 4 fours are 16. Square root of 36 is 6 because 6 6 are 36. Square root of 64 is 8 because 8 8s are 64. Square root of 1.21, see it's a decimal number, but even that has a square. Okay, it has a square root. 1.1 into 1.1 will give us 1.21. So the square root of 1.21 is 1.1. So such numbers like 9, 16, 36, 64 and 1.21 are called perfect squares because we can get their exact square root. Now we are beginning with exercise 3A, page number 42. We have the first question, which is a multiple choice type. Choose the correct answer from the options given below. The square of minus 8, and we have 4 options here. Remember, we just learned from the points to remember, the square of every number, whether they are positive or negative, will be positive. So your answer will have a plus sign, and square means 8 into 8, a number multiplied by itself. It means 8 into 8. How much is 8 8s are? 64. And minus into minus, if you put a minus sign, minus into minus is plus. So the answer is plus 64. So let's see where the answer is. The answer is D, and our answer is option D, 64. Next question. Here we have the square root of 18 minus the square root of 11 minus 7. So first we have to work out this. Okay, so here it's given as 11 minus 7, isn't it? So let's write the square root of, how much is 11 minus 7? 4. 11 minus 7 is 4, isn't it? And what is the square root of 4? That means what is the number which when multiplied by itself will give us 4? 2. Isn't it? 2 2s are 4. So here we have the first step here. So we've got 11 minus 7. So this one we can now write it as the square root of, here we have minus and then 18 minus, instead of square root of 11 minus 7 we found our answer as 2. We can write 18 minus 2. So now this will become minus of 18 minus 2 is how much? 16. And what is the square root of 16? What is the number which when multiplied by itself will give us 16? That is 4. So this is 4 and the sign is minus. Minus 4, which is option B. Question 3. The square root of 2.50 into 10 to the power of 3 is which of these answers? So first we have to work out this 2.50 into 10 to the power of 3. So let's do that. So that is 2.50 into 10 to the power of 3 means 1 followed by 3 zeros. 1, 2, 3. Now whenever you multiply a decimal number by 10 or a higher power of 10, we know that the point will move to the right depending on how many zeros there are. Since there are 3 zeros, the point will move 3 places to the right. So here we have one place here. So let's underline that. So we have 1, 1 and one more place. So in that place, we're going to put a 0 and the point comes after that. So what is our number now? Our number is 2500. Now what is the square root of 2500? Now how do we find square roots? There are ways to find square roots. So one way is to find the prime factors of this number 2500. So let's find the prime factors of 2500. So we're going to divide this by 5. Let's divide it by 5 first. 5 fives are 25 and we've got two zeros there. Continue dividing this again by 5. 5 ones are 5, so that's 100. Again by 5. 5 twos are 10. Let's take 10 and then 0. Next, we'll continue. 5 fours are 20. Now 4 has to be divided by 2. 2 twos are 4 and here 2 ones are 2. So we have found the prime factors here. Let's write them down. So the square root, remember the symbol, the square root of 2500 will be, now all the prime factors we are going to write under this. So how many fives are there? 1, 2, 3, 4. Let's write the 4 fives there. So that's 5 into 5 into 5 into 5. Then we have 2 twos. So that will be into 2 into 2. So what have we done? We found the prime factors of 2500 and we have put them all down here. Now what's the next step? The next step is we have to make pairs of these factors. Pairs of factors, we should be very careful to see that we have the same number. That is, I can't have a 5 and a 2 to make a pair. I should have 5 and 5, 5 and 5. So let's make the pairs. So this will be one pair, both are 5. Again here one pair, both are 5 and here we have two twos. So both are 2's. We can't mix up. Now what do we do? Now we take one factor from each pair. So we are still finding the square root of 2500. Take one from each pair. From this pair I'm taking 1 into, from this let me take one more and from here one more. So that is into 2. So now let's multiply and see. 5 fives are 25 and 25 into 2 is 50. That means the square root of this number 2500 is 50. Now let's look at our options here. In our options we have 5, 125, 50 here. So 50 is our answer. So option C is the correct answer. Question 4. The smallest natural number which on multiplying with 48 gives a perfect square number is one of these. Okay, so we have to find the smallest natural number which when you multiply with 48 gives a perfect square. That means 48 is not a perfect square, but we have to multiply this with the smallest natural number. So how do we find that number? So first find the prime factors of 48. So let's find all the prime factors of 48. Let's begin with 2. Remember we're using only prime numbers. 2 twos are 4, 2 fours are 8. Continue. 2 ones are 2, 2 twos are 4. That's 12. Now 2 sixes are 12. Continue. 2 threes are 6. And here 3 ones are 3. Now let's write them all together. So we have 1, 2, 3 and 4 twos and 1 3. Now let's pair them up, okay, with the same numbers. So 2 we have pairs. Here also we have a pair. Now can you see 3 is a number which doesn't have a pair. 3 doesn't have another number that can make it a pair, isn't it? That means the number that is left out is the smallest natural number, which on multiplying with 48 gives a perfect square number. Let's see that. So here what do? We take 48, it's given in the question, and then we multiply it by 3, 48 into 3. So what will the pairs, now when you multiply this side with 3, you have to multiply the right side also with 3. So we have the 2's here, this is one pair, and then we have another pair of 2, and then we had only one 3, isn't it? Now when you multiply this side with 3, you have to multiply the other side also by 3. So here we have a pair now. Now we can find the square root. So to find the square root of 48 into 3, we have to write all these factors inside, and then to find the square root of 48 into 3, what do? We take 1 from each of these. So that will be 2 into, take 1 from here, 2 into 1 from here, that's 3. That is 2 2's are 4, 4 3's are 12. And here when you multiply these, what do you get? 48 into 3 is 144. And when you see the square root of 144 is 12, because 12 into 12 is 144. So we got our answer. So which is that number there that doesn't have a pair? The number that doesn't have a pair is the smallest natural number. Which one is that here? Option B. This is the smallest natural number, which when you multiply with 48 gives a perfect square number. Question 5. The smallest natural number by which 175 should be divided this time to get a perfect square number is one of these. So here also let's find the prime factors of 175. So 175, let's divide it by 5. Let's take 17, 5 threes are 15, 16, 17, that's 2. So now we have 25, 5 fives are 25. Then continue, 5 sevens are 35. Now 7 only 1, isn't it? So 175, the prime factors are 5 into 5 into 7. Now when you make pairs, now 5 has a pair whereas 7 doesn't have another number. So 7 is the smallest natural number. 7 is the smallest natural number by which 175 should be divided. So straight away we can look for the answer, that is option B, that is 7. Question 2. Find the square of. So how do we find the square of any number? By multiplying that number by itself. So if we have 59 here, the square of 59, that is, if I have to find the square of 59, I write it this way, 59 and square. That is 59 into 59. So I have to multiply these two, and the answer that I get is the square of 59. And when you multiply both, you will see that the answer is 3481. So this is the square of 59. Now we have to find the square of 6.3. So how do we write that? We say the square of 6.3 is 6.3 raised to the power of 2, which is 6.3 into 6.3. So when you multiply, we remove the point and we multiply as 63 into 63. So when you multiply 63 into 63, you get 3969, and then we go back to the question and look at the decimal places. So here there's one decimal place and here there's one decimal place. There are two decimal places. That means in your answer also there should be two decimal places. So the point will come here. So what is our answer here? Our answer is 39.69. The next one is find the square of 15 2 by 3. So let's write that 15 2 by 3 the whole square. We're finding the square of this. So this will be 15 2 by 3 into 15 2 by 3. So here let's convert. Now remember this has just become multiplication of fractions. So here let's convert. 15 into 3 is 45 plus 2 is 47. So this becomes 47 by 3 into 47 by 3. So we multiply 47 into 47, you get 2209 divided by 3 threes are 9. So 2209, now we have to convert it to a mixed number. Let's do that. 2209 divided by 9. 9 twos are 18, minus we have 4, we bring down 0, 40. 9 fours are 36, minus 40 minus 36 is 4, bring down 9. 9 fives are 45, minus 49 minus 45 is 4. So what is our mixed number there? 245, 4 by 9. So this is the square of 15 2 by 3. So 15 2 by 3, when you multiply it twice, you get 245, 4 by 9. Question 3. By splitting into prime numbers, find the square root of these numbers. The first one is 11,025. So we're going to find the square root. So let's put that symbol of square root 11,025. And which is the method we're going to use? By finding the prime factors. So we're going to split it into the prime numbers. So let's begin that. So 11,000. And 25, we're going to divide it by 5. Let's begin with 5. Let's take 11. 5 twos are 10. So what is left is 1. Now again we have 10. 5 twos are 10. Nothing is left. So that is 2. So 0. Then 2 is left here. 25. 5 fives are 25. So we are doing normal short division. Again continue with 5. We have 22. 5 fours are 20. So 2 is left. Again we have 20. 5 fours are 20. 5 ones are 5. Now we can't use 5 anymore. But which number can we use? Let's add this up. 4 plus 4 is 8. 8 plus 1 is 9. That means this is divisible by 3. So let's divide this by 3. So 3 we have. 3 ones are 3. And then there's 1 left, 14. 3 fours are 12. There's 2 left, 21. 3 sevens are 21. So here let's continue to divide this. You can see 14 and 7, isn't it? That means we can divide this by 7. So let's use 7 here. Now take 14, 7 twos are 14 and 7 ones are 7. Now we have 21, we can divide it by 7 again. So 7 threes are 21. Now we can use 3, 3 ones are 3. So now that we have found all the prime factors, we're going to put them together. Now how do we do it? So here we're going to say the square root of 1125 is, we're going to put all the prime factors with the square root symbol. So first let's take the fives, put all the fives together. So we have two fives. So let's write that 5 into 5. Now the next one is 3. Let's take 3. There's one more 3. Let's put the 3's also together. Into 3 into 3. Now what is the next one? 7 and 7. So we have again 2 7. So let's put the 7's together. Now suppose you had only one left. If there was a number without a pair, that means this number is not a perfect square. But here it's a perfect square because there are pairs everywhere. So now let's continue. So here what we are going to do is we're going to take one from each pair. So this is a one pair, this is one pair, this is one pair. So this is going to be 5 into 3 into 7. We're going to multiply all these. So let's multiply. 5 threes are 15. 15 into 7 is 105. So let's write that here. That means we have found the square root of 1125 and that is 105. So this is our answer. Now you can check this answer and see if this is correct. How can you do that? You multiply this twice. 105 into 105. You should get this answer. Then you know that this is correct. Question 3. By splitting into prime numbers, find the square root of 3,96,900. This is the second question. So let's write this down. 3,96,900. Let's begin with 5 itself. Let's take 39. 5 sevens are 35. There's 4 left. 46. So here we have 5 nines are 45. There's 1 left. 19. 5 threes are 15. Then there's 4, 5 eights are 40 and then we have a 0. Continue with 5, take 7, 5 ones are 5, 6, 7, 29. 5 fives are 25 but this is 29 so there's 4 left, 43. 5 eights are 40, there's 3 left, 38. 5 sevens are 35, 36, 37, 38, 3 left. 5 into 6 is 30. Now let's use 2. 15 we have 5 sevens are 4, 2 sevens are 14. Yeah, this one left we have 18. 2 nines are 18. Then take the next number 7. 2 threes are 6. There's 1 left. 2 eights are 16. Continue with 2. 2 threes are 6. 19. 2 nines are 18. There's 1 left. 13. 2 sixes are 12. There's 1 left again. 2 nines are 18. We're just doing normal short division. Now we'll use 3. 3 ones are 3. 3 threes are 9. 3 twos are 6. 3 threes are 9. Again, let's use 3. We have 13. Let's take 12. 3 fours are 12. There's 1 left, isn't it? Again, 3 fours are 12 and 3 ones are 3. So now we'll continue with 3 itself. 3 ones are 3. There's 1 left. 14. 3 fours are 12. Then there's 2. 3 sevens are 21. Now let's use 7. 7 twos are 14. 7 ones are 7. Again 7. 7 threes are 21. Then we can use 3. 3 ones are 3. So now we have found all the prime factors. Let's find the square root of this number. So the square root of 3,96,900. Let's put all this under the square root symbol. So let's count all the fives first. So 1, 2. We have only 2 fives. Let's write that. So 5 into 5. Then let's take the 2's. So here we have 1, 2. Only 2 2's. Let's write that. Into 2 into 2. Then let's look out for the 3's. 1, 2, 3, 4. We have 4 3's. Put all the 3's together. 1, 2, 3 and 4. Then what do we have left? We have 2 7's left. So let's put the 2 7's into 7 into 7. So now what are we going to do? We're going to put them in pairs. So this is one pair. Remember, the pairs have to have the same numbers. So 2 2's, 2 3's, again 2 3's, 2 7's. Now we're going to remove one from each pair. So I have 5 into 2 into 3 into 3 into 7. So one I have removed from each pair. Now let's multiply. 5 twos are 10. 10 threes are 30. 30 threes are 90. 90 into 7. 9 sevens are 63. So 90 into 7 will be 630. So we have found the square root of 3,96,900 and the answer is 630. So the third question in question 3. So we have to find the prime factors of 1,94,481 and then find the square root. So let's begin. Let's write that down. 1,94,481. Now is this number divisible by 3? We have done tests of divisibility, isn't it? So in that, to find if a number is divisible by 3, we have to add up all the numbers. So let's add up all these digits here and see. 1 plus 9 is 10. 10 plus 4 is 14. 14 plus 4 is 18. 18 plus 8 is 26. 26 plus 1 is 27. And 27 is in the tables of 3. 3 nines are 27, isn't it? That means this number is divisible by 3. So let's begin by dividing this by 3. So take 19. 3 sixes are 18. There's 1 left, 14. 3 fours are 12. 13, 14, 2 left. Now it is 24. 3 eights are 24. Then we have 8. 3 twos are 6. 7, 8. There's 2 left. 21. 3 sevens are 21. Is this number divisible by 3? Let's add it up. 6 plus 4 is 10. 18 plus 2 is 20 plus 7 is 27. 27 is in the tables of 3. So 3 twos are 6. 3 ones are 3. There's 1 left. 18. 3 sixes are 18. Then 0, 3 nines are 27. Is this divisible by 3? 2 plus 1 is 3. 3 plus 6 is 9. 9 plus 9 is 18. 18 is in the tables of 3. Yes, it is divisible. So 3, let's take 21. 3 sevens are 21. Then 3 twos are 6. Then 0. 3 threes are 9. Is this divisible by 3? 7 plus 2 is 9. 9 plus 3 is 12. And 12 is in the tables of 3. So we can still use 3 here. 3 twos are 6. There's 1 left, 12. 3 fours are 12, 0. And then 3 ones are 3. Is this divisible by 3? 2 plus 4 is 6. 6 plus 1 is 7. So the 7 is not in the tables of 3. That means this number is not divisible by 3. So is it divisible by some other number that is ending in 1 here? Here it's ending in 1. In which number do we have tables that end in 1? And we have 3 into 7 is 21, but it's not divisible by 3. 7 3s are 21. So is this divisible by 7? So let's try and see. So let's take 24. So 7 3s are 21. And this is 24. There is 3 left. So now we have 30. 7 4s are 28. And this is 30. So there's 2 left, 21. 7 3s are 21. So this number was divisible by 7. Now let's continue to divide by 7. So we have 34. 7 into 4. 7 4s are 28. Now what is left? 34 minus 28 is 6. So we have 63. 7 9s are 63. Now we have 49. 7 7s are 49. 7 1s are 7. So now we have found all our prime factors. So now let's find the square root of 1,94,481. Let's write down all the prime factors that we have got here. So first let's write down the threes. 1, 2, 3, 4. There are 4 threes. So that is 1, 2, 3 and 4. Now let's write the sevens. 1, 2, 3 and 4. So there are 4 sevens also. So into 7, 4 times. Now we pick out the pairs of like numbers. So there's one pair of 3, one more pair of 3, one pair of 7 and one more pair of 7. Pick one from each. So that is 3 into 3 into 7 into 7. So you can multiply this as 3 3s are 9 into 7 7s are 49. 9 into 49. So multiply that. When you multiply, you will get 441. That means the square root of 1,94,481 is 441. We will stop with that for now, children. In our next video, we will continue with the remaining questions. Thank you, children.